old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. What's going on, guys? We're talking some Rodin Coil today. Man, it's been a while since I even looked at this thing, to be very honest with you guys. But since we're starting the other show, man, and we're right on, brother. First hit in the chat. Nice. Since we're going to start working on this thing, man, on the other channel, I figure Wednesdays I go over what I do over there. We're going to start rocking this thing out, yeah. So, a lot of times I just use this thing as something for my Tesla coil, and I put the energy from the center of my Tesla coil into my Rodin coil, and I run it that way, and it makes a great saturation coil. And what I want to look at is the circuit, and this is the one Ben was working on. So let me bring that up real quick. This is a circuit right here that they were using. Up top, you see the two little lines up there squiggly. Those are the coils. It says there's two, and that's because of the way they pull the wires from it. So there's a side A and a side B. What does that basically mean? So when you're dealing with a Rodin coil, you think it's two individual coils. It's really not. It's one coil that's wrapped back onto itself. And it gives you a misconception of, can it be oscillated? Well, probably can't, not in the conventional way you would think of between two coils. It's basically a saturation device. So what you're doing is you're running wire in. It goes all the way to the end of that winding, and then you find it at the other side. And then you connect it back into the winding and run it back all the way through the coil and then to another wire, right? And you do that until you come up with column A and column B. Those are your two sets of leads that come out in and out, basically, of everything. I think I want to change some of that and individualize it, get little bars in there, and individualize each one coming out. I think there's an over unity reason for that. But let's take a look. So if you run them all together as two units there, you're going to get two sides to it. So what they did was they put the positive side in on both sides of the coil. Pretty simple. Comes out on both sides. Now on the middle side there, I will say we're going to resistor 1. They have a resistance, and then they have a potentiometer, which is more resistance. And they bring that into the base of the transistor. The other side of the coil runs off, and it goes into the emitter side of it. And then the collector side goes back down and routes back to the negative on the power source. But on the other side of that, you got the neon bulb over there. Now, 90-volt neon bulb. Here's the thing. In looking at this circuit, just understand this. With resistor 1, we're getting heat. With resistor 2, we're going to get heat. With neon bulb, we're going to get heat. We're in a positive system. Our enemy is heat. We need to reduce that. This is going to be not so efficient when we run it. This is the conventional circuit that Michael and also Ben were using. And I'm sure it works in a normal fashion. You basically get saturation in the coils is what you're getting. The saturation should add extra energy over time to everything. And once it's started like that, the jewel thief itself is designed to use that extra energy to be able to turn on a neon bulb. That's what it's designed to do. What's the problem here? Well, if you've ever seen me do this, I run my transistor right off of my Tesla coil. And I could start up another Tesla coil with it pretty easy just by putting a rod down the center of my Tesla coil and using that frequency in order to run a transistor. The problem here is you got so much resistance going into the transistor. You want that base frequency to be set. What are we missing? We're missing a frequency generator in the circuit. We're missing the frequency of the coil itself. It's not really a mini slayer. This is the way the jewel thief set up. So we're not getting anything that's going to help us here. We're just putting whatever into the coil. You see, we have to run the radio frequency test on the coil itself in order to pull the frequency of the coil. So once we have the frequency of the coil, then we put in that frequency directly into the coil. What is that going to do? So I'll take this down real quick and I'll just tell you. Once you get the frequency of the coil itself, it removes resistance. You see, because we're going to get a lot of resistance coming out of this thing going into that coil, and it's going to heat up the coil. In order to get rid of the heat going into the coil, because it's going through positive first, we are going to have to find the frequency of the coil. Once it matches the frequency, it runs through without impedance, no heat loss. Okay. If you don't do that, you're automatically going to have hysteresis. You're automatically going to have heat loss. And the amount of power going through this thing is going to go down. You already have too much loss. You're going to lose 20 to 30% right away just in that coil, heat right up. So you want to remove that first. Okay, that's the first thing. You got to get that frequency to remove that heat. The second thing is the resistance and potentiometer. We don't need them. Just don't need them. You're just backing up the energy. Okay, and it's in there because your frequency is wrong in your coil. That's why it's in there and in the amount that it is. Once we remove that, now we can get the energy to go into the base right. Okay, so now we know that the base itself is going to go right in here, right? So let me tell you something about a transistor you need to know. Okay, transistor is an amplification device. It's not just a switching device, it's an amplification device. So basically, when they came out with this thing, they were looking at a way that they can amplify the signal in the Bell telephone. They wanted to be able to hear people from overseas a little bit easier by amplifying the signal. So how did they do it? When they put the energy into the base, it connects the emitter and collector together. So the emitter and collector, so think about it this way. You're going into the emitter, it needs to connect down to the collector and go out. Okay. In order to do that, your base must come in and saturate both sides in order to have that connection complete, right? That's your switch. Once it's complete, right? You want the base that comes into it, always from the side. Just right here, you need that to be an over unity thing. It has to be over the amount. Okay. You want to take those two leads that come together, connect them, but you want that base to come in and add energy to it. That's what it was designed to do. It's not just a switch. It's to add energy to it. If you think about it in that fashion, that's what we need to do to this circuit. So we'll put up the circuit again. So right here, as we go from that potentiometer, which we'll remove, going into the base, that has to add energy to this. So what's going to happen is that the frequency is wrong. Coming out from the very top of the coil and going back down, it'll split off between that and the neon, and it will add the wrong frequency here, which will make this thing do work and heat up, and it's trying to adjust to the frequency coming into the base. This is why having that coil itself in the correct frequency is the most important thing. because we're not fighting it. Once you fight it, you start adjusting it. You'll start seeing the frequency change, the amount of volts and amps will change in the entire circuit. And in that transistor is where the conversion will happen. When it does, the transistor itself heats up. That's an energy loss. We can't afford an energy loss in this. We must have the frequencies coming in the correct way. Now, when we look at the neon bulb, we're not in cold energy right here. We're in positive energy going through the coil. The neon bulb just eats up energy. That's all it does. It eats up energy. Why would I want to eat up energy? I don't want to eat up energy. I don't want an energy loss. That has to go away. We replace that with a capacitor bank. So now, and we put a diode right before it. And the diode is simply to say, once it goes through there, we're not giving any back. Okay. We'll put that in there and we'll detach the line that goes back off to the collector side of that transistor. So we'll isolate where it says neon bulb, a capacitor bank in order to pull the energy out. So what does that mean for us? On one side of the coil, we're getting extra energy that comes out in the capacitor bank. On the other side, we're running the circuit through the coil and down and back through the collector and back to the negative. That means that we have a loop there, the frequencies are correct, and we basically have a system that runs. It's DC, it's a closed loop system, right? What does that mean for the other coil? It means that on that other side, what we're looking to do is pull the energy directly out of it. We want to take that energy out where we can. It'll still go over to the transistor when needed, but it'll pull over to the cap bank when it's not. That's what we need to do here. Yeah, we just need to change the circuit a little bit in order to make sure it runs for us. Again, the goal is when you go from the positive and you go down to where it says the resistor, we need to eliminate the impedance. Then we need to go into the transistor and then back to the negative. If we can get that loop with as little loss as possible, hopefully a little bit of a gain will come into it to eliminate any loss that the transistor may give you initially, then we should be able to loop this thing. Now, if we can pull that off, the other side of it, the cap bank, is to pull out a little bit. Now, let me just explain this. The way that I explained it is exactly how Tim Tron does it when he runs his mechanical device to get over unity. When it goes into the cap bank, you add it back a little bit to the main system in order to keep the rotation going in those motors that he's using. You see, that's the trick here. We're in solid state. He's in mechanical, but it's the same thing. It's the same idea, same principle. One loops back, the other pulls out energy based on the saturation rate of that coil. If we do it without loss and use the correct frequency, we'll be okay. It should start to work out for us. It's about tuning after that. You do not want a resistor in an over unity circuit. It just causes heat. It's an absolute no-no. You never have it. No potentiometers, no resistors. You do not want the neon light unless you're in cold energy. So if we're in hot energy, we can't afford the neon light. It's too much energy. Once you get it past the cap bank, you can do whatever you want with that energy. I don't really care. I mean, run anything you want. Once caps fill up, you're good to go. We need to start running this where we start thinking bypass valve between the positive and negative of the actual circuit, so that we can look at having a battery in there and having a bypass switch that we can bypass the battery to run it back into the system. Now, will it require a little bit more from the cap bank sometimes? Maybe. It might, depending on how we tune it. It may require a little more. But that's what we're going to have to give it until we can get that loop set and then pull the extra energy out. Another advantage to this is, where is the zone to pull the energy out on top of this? Well, if you look at the Rodin coil itself, it's a big donut. So where's the extra energy? It's right in the center. And what we're going to get in there in the center, if we do not create too much heat, if you create too much heat, you won't get it at all. If you keep this thing cooled down, in the center will develop a zone in there that'll have extra energy in it. That would be your ether point. Okay. The problem with a lot of this is we run it in positive. When you run it in positive, an ether part's very difficult to get. Most coils will not give it to you because normally you don't even think of putting it in the correct frequency and you just run it. So you'll never see that ether point. When we want that ether point, we're looking for negative energy to go in first. That's normally when you get it. You can get it in positive. It's just a really hard sell to do. Now, if you can get that, then you can pull any extra energy you want out of that. So that's kind of the cool thing about this, is we have a couple different ways to go. Let's take a look at the circuit again. If we look at this and we erase where it says positive up here and we put a negative in there and then we leave the neon light, that basically means that we're pulling the negative through, which means it's going to be cold energy going through the coil. There's no hysteresis in it, no heat whatsoever. The neon bulb is the draw. It goes between your emitter and collector, and that's exactly where you want it in a cold energy circuit. This is why it's probably confused in this way. Somebody tried to run a cold energy circuit with a hot energy circuit and it failed. When you run the negative through first, then you can pull the neon. It'll act as a draw, but then the capacitor bank goes behind the neon. So you want the draw, but you want it to pull into the cap bank. The other side would pull through no problem, go to the base and run back all the way through to the positive. And you have to use a battery in this system if you ran it in that configuration, which would be the negative configuration first. So there's a lot of good things about this, but it's two separate circuits that looks like they got confused on how to run this. All that resistance potentiometer, that's all because it's in the wrong frequency. Once we remove that frequency problem, that goes away. We don't need it. You got to understand, you have to set the frequency to the coil. The coil, you have to map out the frequency. It's not hard. It's a radio frequency method. You basically take a 10K ohm resistor, you put it on there. You take your frequency generator and you run it to one side. You take your oscilloscope and run it. And you're just looking to run it through the frequency generator until you scroll through and hit a point where it spikes. Once it spikes, you go, okay, I'm gonna write that number down. How much does it spike? What is the amount that it's going up? Okay, that's all we want to know. Then you go over to the next one and you find another one and see if it's a higher spike. If not, go back to the first one. You do it a couple times in there and you scroll through these signals until you find the highest spike possible. That's the frequency of the coil. That's telling you right there, that's what this thing needs to run at. So in the beginning of that circuit, we must have a frequency generator to get to the coil's frequency. That means zero impedance. When you don't run it at the frequency of the coil, all you're going to get is heat. You're going to have heat build up. You're going to have a problem. It's going to start hysteresis, and that just means you're going to blow out heat everywhere. Completely useless for the circuit. So we have to do those several things in order to fix that circuit, in order to get it to run for a Rodin coil. And this is going to be the same thing when it comes to a geometry coil. There's going to be not much difference there in the way we look at this thing. Again, the Rodin coil is one coil folded back onto itself. The geometry coil is two separate coils. So you will get resonance in there. And you'll be able to run that thing a little bit more like a Tesla coil than this circuit would be. Now, can we put two coils in this Rodin coil? Sure we can, if we really wanted to. What's the problem? Is it's one coil wrapped and another one over top of it. So the length of the wire will not match. It just won't. Nothing you could do about that. The inner is always going to be smaller than the outer. And that's going to cause a problem. It's not going to do well for you when you run the coil. and it'll always cause a mismatch, which means the resonance will never be right in between it because you need equal frequencies in it. Okay, timing's one thing, but the frequencies have to match. So that's out. So there's no way to get around that. This is a one coil system when we do this one. In the geometry coil, we can play with it because we have two coils that are matched perfectly when you wind 180 degrees out, immediately winding it together, you should have it. And because they're pulsed separately, you should be able to put energy in one, then pulse to the other one. And that's fairly simple. Okay. The worry is cancellation, but based on the way that you wind this thing, you can avoid cancellation altogether. There's a trick to it. So anyway, that's kind of the thing on the Rodin Coil. I just wanted to start out the Wednesday with this is where we're going on my other channel with this. And that's where I'm going to start, is right there. Is we're going to go walk right through the Rodin Coil and start explaining it right away. And then maybe we might build a Rodin Coil so I could still show everybody, from the start. I wish I had more wire right now. It just hasn't come in yet. I would just wind it first and then go over all the circuits because that's the proper way to do it. And if it gets here before I start, then that's what I'm going to do. So, yeah, that's unfortunate, Ian. I did see that, and that sucks that somebody is that stupid to do something like that. So many stupid things going on in the world today, man. I cannot believe it. I have trouble watching the TV myself right now, to be very honest with you. That guy in that train car, man, that guy, they need to put him in the electric chair in the middle of town square and then light him up like a Christmas tree. That guy doesn't deserve to live. Okay? Either does this shooter. Those kind of people, man, should never be in society. So I'll leave that where it is, but I don't like any part of that garbage. Those people need to go away. So anyway, yeah, Pressure with his family, man. Yeah, lead acid battery. We're going to use that with the Rodin Coil. So one of the other things we're going to do is I got some other lead acid batteries. I want to see if I cannot recycle them and get them back to life. You got some out of a scooter, and I'm going to buy a couple more. And those are the ones I'm going to use in this. And we're going to be pulling a Bedini as soon as I can find all the parts that I want to use for it and get them at a decent price where I can afford everything. I'm just going to make myself a Bedini circuit so I can just basically fix those batteries so that we can use them in negative energy for everything. So, yeah. Yeah, the Rodin Coil is going to be nice, man. I got the Joker Coil, which it lights up like bluish purple at nighttime, man, once you charge it, you know what I mean, or put some black light on it. Really cool stuff, man. I want to get a second one. So I got 20 gauge on that one. I'd like to get to 26 gauge. I think the lower gauge, maybe adjust the size a little bit, get a little smaller. The amount of discs may change as well. I'd like to build a second one smaller, then start changing the discs out to get different numbers in there. I don't like uneven numbers in that. I want to make sure it's an even number, and it has to do with secondary systems going into it. One thing Ben did do, just so we all know, is he ran a coil underneath his Rodin coil and was able to pull extra energy out of it. So pickup coils will be something that might be a big thing for cap banks. Every little bit that trickles in, man, helps. So if you just basically have a coil on top and we put a bifilar coil from Tesla, one on top, one on bottom, how much more energy do those pull out? You know what I mean? Can it expand the energy coming out of this coil when we run it? I think those things are going to be pretty awesome. Yes, I will. I will post every single thing that I do with those coils. I use just a conventional one right now that I found on Thingiverse, And as soon as I start making new ones, I will absolutely post them. I generally post everything that I do in my Thingiverse account. If you've ever gone to there, you'll see quite a bit of stuff, but I'll start posting all the Rodin Coil stuff there. And geometry coil frames will be on there as well. So yeah, not a problem there. So use the Rodin Coil primary with multiple frequencies. Well, see, that's the thing. There's only one frequency in that coil that's going to work. There's not more than that. I'll just tell you that right now. I'd be disingenuous if I told you more frequencies would work. There's one frequency in that coil based on how you built it, and that's it. Once you find it, things will run smooth. If you start messing with all the frequencies, it's going to be a disaster. It's just going to be a disaster. I ran this thing on a ZVS once, and I just wanted to see if I can ping it back and forth. And the answer was yes, I could, and I can get it to have a beautiful ring to it. These coils, because of the way they're wound, they like to heat up. So the colder the circuit is, the better that runs in this thing. And I think by the time we're done, we're going to find that cold energy circuit's going to work way better than a hot energy circuit ever could. And that's usually the case with most of this kind of stuff. Let's see. Yeah, right on, brother. Bedini stuff. Yeah, if you share any of that, be great, man. I looked at it as I think I just want a small one, man. I'm just gonna make a somewhere around a 12-inch round disc thing. Kind of like the one I did for looking into Mike's thing when I'm going to start with my pulse coil when I do it. Kind of the same thing. Not a lot in the frame, heavy on the outside, magnets attached to it, and we'll run it. And I think that's where I need to be. It's one coil. It's not overly expensive. Buy a couple of 2-pound coils, put them together, and put another wire in there for the trigger, and then we're good to go. We'll wrap it just like you said, spin it. That's not a problem. I have a thing set up in the backyard for the length that we need, and I can spin those with my drill, no problem. So that'll be fairly easy. I don't think there's much more involved in that. Circuits are fairly simple. I mean, we know exactly how to build circuits, so that should be easy. It's only one transistor if you're just doing his normal circuit, and if you're doing his multi-coil system, it's like 4 or 5. I see no problem with getting through that. That should be, once we have all the parts, that should be like a weekend's worth of work. It should be fairly easy. Probably take me longer to print it out than it does do anything else. Let's see. Nice. Yeah, we'll do the Discord once we start up the builds on that. We'll be doing the Discord on that. I think I'm going to use Mondays to talk about the Tesla coil stuff we do on my normal channel, and then we'll use Wednesdays to talk about the Rodin Coil and geometry coil stuff. And then Friday, me and Joe will hash out whatever goes on during the week, or we'll just come up with a different topic. I think over Unity is the topic for Friday, though. We're looking at the the ether and a little bit over Unity. I think both those are going to come up on Friday. Yeah, printing. I have a printing channel. I'm going to start firing that sucker up and do all my CAD work on there. So as I change things, you'll be able to see everything on there. What I change, and then the publishing of the STL, stuff like that. How I use Fusion 360 to do everything. And then, basically just tips and tricks to get you through it. Some of the people that I like to use for my 3D printing, I got old CR10s here. So nothing's overly complicated or out of anybody's budget. I mean, they're $100 printer. We're not going crazy here. We're just going to do simple work, put it together, and all the stuff I'll do on my printing channel is going to be based basically on what we do for the other two. So whatever we're making, you know what I mean, in either one of the channels is what I'll be publishing there. And then I'll have always a direct link in the description of those videos for my Thingiverse. Okay. And then, you know what I mean? Anybody who wants to help the channel or anything like that to help it grow, then I'll put the link at the bottom for like my Shopify account or something like that, where you could buy it for like $3 or something. And that's just to help out the channel if you want to go that route. If you're like me and have no money, then Thingiverse will be the thing for you. So either way, yeah, it's Friday 0 point energy. Yeah, well, they're kind of the same thing. You got to understand that ether and 0 point are the same thing. So yeah, that's what we'll be talking about, Paul. You're absolutely right. So yeah, those links will all be in there, guys, and I'll start putting out all the links for everything as I go forward. I just want to set up those channels properly and have my cameras set up and everything. You can see behind me this side. That's my Old Man Build logo. I'm going to be moving to that desk behind me. You see the chairs over there. That's going to be my normal, podcasting station or whatever you want to call it from here on in. That's where I'm going to set up. I have a little arm that goes on the side of that island right there for my TV, so I could set it up permanently with my computer. A separate computer for that. So, yeah, we're going to be, doing pretty good, man. Setting everything back up, just having, everything match and look really nice. I got a spot over there. I got to paint. Sorry, I missed it. Got to hit it. I did a Spider-Man behind my 3D printers, man, some posters and stuff. So it looks cool for when you film. So I'm pretty excited, man. Everything's starting to come together finally. It's taken me a long, long time to get this thing set up because I got to set up workstations where you can see everything overhead. Lighting's got to be right. I had some problems with lighting big time. So I'm going to try to square that one back up. Get back on the whiteboard, man. You know what I mean? Get everything going because, I had to get everybody's stuff out of my garage. I was just, I've had it, get rid of it, or I'm throwing it away. And that's the way I just decided to do it, man. So, get old, you can't deal with it no more. Right on, brother. I appreciate that, man. Thank you very much for saying that. Awesome. Bring a gas generator. What's going on there? Display 0 point, man. Yeah. Yeah, well, hopefully that, you know what I mean. Once I get that thing set up, put out the link for it, man. Hopefully you can get, at least to the point where you can build out your Tesla coil bases and stuff like that when you want to change them. So, and it's really cool, man. You go in there and you take your old files and get them and change them out to the size of the actual pipe that you get because they're different everywhere. So that's what I do, and I have a certain setup that I use for it. Once you understand it, it'll be fairly easy. So, yeah. Nice. I did like that, by the way. Darren printed out, and I wish I would have taken a snapshot of it. He did the Old Man Builds logo on his Tesla coil, which generally I don't put on the Tesla coils when I sell them because I don't know that people want that. But I made one special that says Old Man Builds on it. It's on my Thingiverse account. And yeah, if you put that one on there, it looks awesome, man. He's got, I think, two bases that he printed out. So, and he's got his first coil he got, and I sent him a second coil to send him an actual extra coil for that since he burnt down his first one. So, yeah, it was pretty rocking, man. I love that when I saw it. And he got the big boy printer, man. He's got the, what is it, like 400 by 400. So those are awesome. Yeah, but we're going to be building stuff out, man. The first thing on the list is the Rodin Coil. And then I think what I'm going to do is we'll work on it. We'll start working on the circuits, get at least the video for the build and the circuits out. And then I got to go right into the geometry one. I'm going to just do them side by side. So, and then we'll work on each one for at least 30 days before we move on to a different design. But I kind of want to keep things fresh. So if I have enough money coming in, man, we'll be doing a design on each one of them every month. So one Rodin coil design and then one geometry coil design, both each month. So that'd be pretty cool, man. It'll give us a chance to get through some stuff because when we get to the geometry coil, it's not going to be as easy as we think it is, and we're going to stumble a lot along the way, but it's going to be well worth the ride. So, yeah. Well, I'm expanding, man, is what I'm doing, and I'm trying to put everything in place to do it. By the way, I got to mention, just so you guys know, um, I have one of my Tesla coils on sale. Just as a shameless plug here, I'm going to give it to myself. At the bottom of the video you're watching, you probably see the store in there for my Shopify account. I have an NPN Tesla coil for sale in there. I put a tip on it. You can see it behind me. That one right there. I believe I put it up for like $260 on there, man. It's a sweet deal. All you need is a power source for it. That's about 30 to 40 bucks. And then I'll be doing a power source for some of this stuff eventually. When I have enough money to make sure I can buy it with it. But yeah, that's it. Normally I say buy it at Amazon because you get a refund if you blow it up. But yeah, I'll be starting to add those to it. But right now that one's on sale right there. I also dropped the cap banks and some of the circuits by 20 bucks, man. Helps some people out. I mean, some hard times. And if they want to be able to get into this adventure, you absolutely can. So just check that out at the bottom of the page there. You'll see all the listings in there, and you can check it out. Why not use a coil like Don Smith? Don Smith coils, we'll eventually get to those. That'll be on my primary channel. When I do my other Tesla coils, that, yeah, absolutely will produce more amps. There's no question about how that one works. Right now, I'm not set up to do all of it at once. So I'm only one old man. So I want to get my geometry coils up and going, and I want to get the Rodin coil up and going. I have a few more geometry coils I'd like to do for my Tesla coils before I move on to any kind of Don Smith device, because it requires quite a bit of initial investment when you start buying stuff. But yeah, that will be down the line, absolutely. No question about it. One of the other ones that we'll be doing on the geometry coils is the Death Star from Sean, which is the round Tesla coil. I want to build one of those. Now, let me say, in the last one that I did, the U-tron shaped one, I have to rebuild it one more time. And that's the files and everything. And here's the simple reason why. When you go to spin one of these, a 1/4-inch rod is flimsy as heck and is junk. Just junk. So what I want to look for is a wooden rod with a bearing combo, one where I can find a bearing that'll fit around it. Sorry, and it'll do good. If we can get that, man, then that's what I want. And there's a reason for that. Energy comes out of both sides of a bipolar Tesla coil. And I don't need that thing going off. I need to put a heavier piece of metal on the end of it so that the energy stays within it, kind of like your top load would do. We don't want energy coming out of it unless it's coming out of the actual coil itself, which we want to use that. I'm not putting it in AC, so we want to use it in DC. Therefore, we're not looking for all the big sparks. Now, the one I got, I'm going to transfer that one over to AC. That's going to be a monster one, man, blowing it out both sides. But on the next one I build, I'm looking at 3/4 of an inch of a wooden rod, so I can start running this thing at 4,800 RPMs. I want to get this thing up and cranking pretty hard if I can. That requires a, for lack of a better term, a harder shaft. And that little quarter one, it ain't gonna cut it, man. It's too limp. So we're gonna have to get a harder shaft to work for this thing, man. So that means it's gonna have to be a little bit thicker. So we'll just redesign the STL, which won't take very long, and then we'll run it that way. And I think we'll be better results in spinning the thing, because the last time I spun this thing, you get it up, a couple hundred RPM, and the thing's wobbling, man, like crazy. Joe says it's like my gravity flyer disc. It's got a permanent wobble to it. Anyway, no, that's gonna have to change here. When we do the next couple ones. So I learned it in that one, and I'll continue that for the next couple. We may do a small version just for AC, but for DC, it's going to have to be a little bit bigger in the center. Can't get away from that. That, and I get a chance to redo the, epoxy on the outside. I wasn't as good as I should be at that, and I think the next one will go a lot better. Yeah, people like to make everything too hard. Well, sometimes we're looking for different effects. I mean, you got to understand this. Yeah, an acrylic rod might be all right too. I agree with that. But I want to get a wood dowel because those things they take some beating, man. So, can't use metal in it. That's the only thing. It can't be metal. It can't be anything like that. So, what was I going to say? Sometimes in every coil, you're looking for a different effect. I mean, you got to understand that. Not everything is going to be to run another motor. It's just not. It's not the effect we're looking for. In a geometry coil, sometimes I might just want to change the temperature in my room. And we could do that with a geometry coil. We'll just flow the energy inside the room into the coil, and we'll be able to cool it down, make an air conditioner out of it, which is 100% possible with one of those things. But, you know what I mean? Every coil has its own design, and the goal of this channel is to find out what they are. Sorry. Still getting over my cold. My goal is, guys, before next Tesla Tech, I want every single kind of coil and device I can build in cold energy before I get there. That's my goal. And I'm going to put the pedal to the metal to get there. Okay? Whatever I got to do. I don't care whose toes I step on this time. It's just got to be done. It's a race towards Tesla Tech. And that's where I got to go. And I've been waiting for a long time for other people to do stuff, and I'm at the end of it. I'm going to run it myself. So I generally get systems pretty much perfected fairly quickly because I know what I'm doing. So, like I said, man, we're going to rock this thing out real good. Carbon fiber is another one, though I have seen those break down and just shatter. Let's see. Can I run a Tesla coil with a hairpin circuit? Yes, I can. I absolutely can. I've done it. I've done it on this channel. You don't necessarily have to do the hairpin circuit. Just the FYI, put the wire down the center. It does the same thing. It's all about how you change the capacitor in that and where you pulled it. We could run a conventional one, yes, and it still will work properly. As a matter of fact, it'll use a tin foil secondary and turn it on. So yeah. Yeah, sorry. I was drinking a lot more. It's like a love-hate relationship with Gatorade and stuff like that. Anytime I have that kind of stuff, man, it inflames my body, so I can't have it too much, but I needed it. So yeah, kind of ruins everything. Cold came up at a very bad time for me, but thankfully it's almost over. I appreciate you looking out for me on that. Yeah, I'm gonna go with the wood at first, and there's a very particular reason because I like to set things on fire, and carbon fiber may not work so well for me. So the acrylic maybe that might be good, but I'm gonna go with the wood, and here's why: the outside's a bit soft, so if I have to thread it through something, won't be a problem. You know what I mean? I think I want to pin it though. You know what I mean? Just kind of like you do your wheel bearing, how you put in that nut and you have that pin. I think I want to do that to it. So, uh, yeah, basically, just so you know, when you go to look at the inside of a coil, and this is where you're going to find the ether aspect. Everybody kind of wonders what it is. It's basically negative energy that comes across the inside of a coil. It's the impulse of it. It's the compression of it. That's what it is. That's what it is. No getting around it. It's unmistakable. It allows you to build the Casimir effect without any kind of plates whatsoever. It'll do it in the energy itself. And if you know that, then it's pretty easy, man. It's kind of one of those things that if you look into anti-gravity and you do not have that, you'll fail. It's a fundamental part of anti-gravity. It's the impulse. You must have it. So I could talk all day on that one, man, and how I found that and how it changed everything. But you have to have it. Well, that's a bit different than the B field. So you got the A field on the outside, right? And that's your magnetic field. Then you got your B field on the inside, which is your Tesla coil winding. But then there's a field inside of that that's the impulse. You see, it's the inner part of that B field that you need to be looking at. And I say it in a different way than just the B field, only because there's a bunch of wire and there's PVC pipe obstructing it. But inside that center is the impulse zone. That's where you got to find it. So yeah, technically the B field, but there's really more definition needed to add to that to say it right. It's because of the windings that go up in the B field that cause the compression down the center of it as the impulse. So the impulse will actually pull in the energy that you're looking for. It'll take your ground and make it a pump from the ground into the coil versus the conventional way of the coil blasting out energy on the outside. So if you understand what I'm trying to say here, the outside is traditionally what people think of when they say the B field, the outside of the number 2 coil blasting out, okay? That's generally what they perceive it as. But the trick is the inside of that B field, okay, is where you get the impulse. So I always say that with a caveat because of that. And you could get lost in the fact if you didn't know that. It would change how you see the B field in something. So, yeah, we straight up, Sean was pulling lightning bolts from the ground into his coil by using the impulse itself. And it's 100% true in how you do this thing. So, hopefully that was understandable. I should probably find a better way to phrase it and to draw schematics on it. Because sometimes, man, like I said, people just get lost and they only think there's 2. They don't see the impulse area of it. And when you're looking at, say, geometry coil, right? Each layer is a layer of that impulse zone. So it's like I want to say it. If you want to call it scalar, it's like a layer of scalar each. And because you get that layered effect that goes on in there, it causes capacitance in each layer. And then in between that, you're going to get a static layer that builds up because of the friction between the capacitance layers. So inside that geometry coil, you're going to get a massive amount of power down the center of that thing, okay? And you get a little bit of heat on the outside. Massive power on the inside, a little bit of heat on the outside. But it's going to work to your advantage because once you start creating capacitance in the center, and you create that impulse, remember it's an impulse, it's going to pull in that heat. It wants to pull in the heat. But what it does is because those things are a capacitor to the environment as well, the air itself starts to move. You'll get the air movement to go inside the center of the coil. Once that happens, it works as a field that goes pulse up, pulse down, pulse up, pulse down, pulse up, pulse down. But the coils themselves are meshed inside of each other like this. They're 180 degrees wrapped right over each other, just like this. So as you get that movement between the two, it's like this. So that friction in there creates that static layer in there. But that static layer gets involved in the environment and starts pulling the air itself in because the energy's in the air. You know how you make static going down the hallway in your socks? It's the same thing. So you're pulling energy through that coil based on the environment. Now you have a different coil system, and the reason you use the geometry coil in that way is to take advantage of that center zone. The Tesla coil does it, it's just not as efficient. Yeah, it's just not efficient at what you're trying to do for that. So it'll still create the null zone that you're looking for, which, by the way, most people don't understand that one. Anytime you take a Tesla coil and you connect it to another Tesla coil, and that second Tesla coil sitting there, you're probably going to get a null zone in the second Tesla coil because there's no primary on it. Once you do that, the center of it becomes null. But that also means that when you're running it into another device, you can create a null zone or a negative zone or a neutral zone inside of whatever device you run it into. That's why you put the wire down the center. You want to create that. So when I do my gravity flyers, exactly how I create a null zone in the center of it. That way I can pump it with the top disc and create a capacitance within it. And just do this effect all day long. It'll pull the energy right out of the ground. It pulls it right into there, fills it up, builds the fields for me, does all my work for me. It was just a simple understanding of what you're trying to do. And you probably got to build hundreds of Tesla coils like I have to figure it out, but I gave you the answer for free. Yeah, because you say ions in the air. Yeah, you're working with the air itself. I mean, we're in an energy field. It only makes sense to take advantage of that energy field. I mean, you have to start seeing it that way. You're not creating the energy. The laws of physics already told you it doesn't. Everything comes from the primary source in the cosmos, and inside the planet, it comes from our ether inside the planet. So we're in an energy zone. So all you're doing is pulling that energy through your coil. You're just finding a better way to get a hold of it. The Tesla coil showed you when it does capacitance to ground that the energy was already there in the air, that you're already taking advantage of it. Just remember that. Capacitance to ground is a Tesla coil. So you're taking advantage of it already. Now you're moving it in a geometry coil the correct way. See, a lot of people think they're just flat coils. They're not. See, they build out energy in a huge field. So, yeah. Old tech used electrostatic machines. I wish they would have built a lot more electrostatic motors, to be honest with you. Those things take advantage of a lot of things that go on in the environment. Yeah. Understanding the D field. Yeah. You're reprogramming them to respond to a load differently. Absolutely. Yeah, I agree. Sorry, I'll put up the comments, guys. Yeah. So like I said, it all depends on what you're looking for, man. If you're looking to create something that has usable energy right away, you're absolutely right in Don Smith and the way that he does things. You get you more usable amps right away. The fun of some of these coils is conversion process of how you can outsmart things. And hey, can I take this other stuff and do it? Can I pull in the environment and pull the energy out of it? Can we use that radiant field Tesla talked about and pull it right into our coil system in order to use it? Because that's the next step. And that's why you have to learn to do all these things. Because when you get up there, you want to make the outside of your UFO a transistor. You want it to have a property that gives you over the amount, but you want to be able to pull in the energy from the environment with it. So you're going to use metals in there that are conducive to a transistor. And you're also going to want to make things that, have different levels in them. For instance, oxides on the surface is not a bad thing because it works as a mini diode for certain things. You're going to want different metals in there that'll amplify quickly in radiation, and that's what you're going to find up there. So one of the things is bismuth. When you have aluminum, bismuth, aluminum, trust me, you're going to be dealing in radiation real fast. And once you do, to amplify that radiation, you need the bismuth. And it's also going to work as a sealant because it's going to turn to lead on you. And it's because of those factors of which you want to use it for. A lot of people think you want the crystal bismuth. It's not the one you want. You want the extra ions in the lead. And it's how you use those materials and material science to get there. So, yeah. Yeah, Don Smith runs stuff frontwards and backwards, but he runs it in a harmonic way in order to pull the most energy possible out of it. You know, man, who was doing that lately? I just saw somebody do it. I'm sorry, I'm drawing a blank right now, man. I just watched the video a couple days ago. He's been on it for a while. When I think of it, man, I'll get it back to you guys. But there's somebody out there working on it who's doing a really good job. Jamaica dudes, I don't know where that came from or what that's about. Did I see the missile bounce off the orb? No, but it doesn't surprise me. Joel, that's right. Joel Legacy or Joel Legance. Yeah, that's who's doing it. I don't know why I didn't remember that. I know Joel actually pretty well. Yeah, he does a marvelous job of showing that. He started out with two windings where he showed you the ground in it, and it was just for a ham radio. He was doing it, and he made 2 wire windings and one on each side, and show you how it works in order to put the frequency between 2 lines, which is a perfect example, by the way, of how to do it. He did a great job in that and showed you exactly how it worked. And then he went on to more of Don Smith's stuff. So, dude, and then he does the peg cell. I think he did the Joe cell, but I know he did the peg cell. So, yeah, he does a great job, man. He came on the program with us and had a real good time. So I think I'll ask him again to come on and present for that. So we'll see if that'll work out. Nice. Yeah. Gotcha. Something. Dealing with something I wasn't dealing with. Okay. Yeah, there's a lot of stuff in the news lately, man. They're up on Capitol Hill talking about UFO disclosure, which basically means they're going to write another book and get another paycheck. I don't see anything coming out of that. Yeah, just a bunch more people on Capitol Hill doing the same thing. They did it last year, doing it this year, same group, same lack of disclosure going on, and for everything to bring out, we've already seen it. I mean, I've already seen their party tricks, so time for something new, and I haven't seen it. Sorry, I know everybody's interested. Everybody wants to know if there's UFOs out there, but that group ain't going to give it to you. They've had what? They've been in the spotlight 20 years. Greer has. Guess how many things he's shown us about a UFO? There you go. There's the number. That's it. I know a lot about the fact that he has government contacts, that he briefs presidents, that he's able to talk a lot, and the amount of stuff that's actually known. Big fat zero. Sure, you could say they have it. Sure, you could say that all these different corporations are building something like that. For God's sakes, who wouldn't? I mean, who wouldn't want to build anything like that? But past what the government's shown you in the triangle craft and other things like that, that you know that they have, what else was there? I mean, what am I missing here? What's the big deal? It's not like, hey, we hot wired one and we're floating it around and you know what I mean, we're rocking around everywhere else. I mean, that would be something cool. That'd be like, oh, you're going to jail because you stole a UFO? Dude, I'm all in. I'll watch that all day. I have no patience for something that goes on Capitol Hill and tells me absolutely nothing more than I knew before. Yeah, but they make a lot of money on their books. They get a lot of views. If you mention their name on YouTube, you get a lot more views. You know what I mean? They are the disinformation campaign. That's what people don't understand. They are the disinformation. They get you all excited, like ancient aliens, get you all excited for something. There's no payoff. Never. All excited for it, no payoff. What's up, Ian? Thank you for sending me those files, by the way, Ian. I really do appreciate that. Huh. Yeah. Well, Sal Paez actually has something it's an invention. And it's not so much of what he wrote down, because some of that stuff, yes and no. It's because of how he describes it and what he saw. And I know it sounds crazy, but you're going to see the same thing when you start building these things in that field. Oh, yeah. Well, it's easier to make it if you understand it. Absolutely right. That's why good old Admiral Jack, or like we like to refer to him here, but Jack Stafardi doesn't have it. He wrote a paper based on somebody else's work on an anti-gravity field. I could tell you that because when you read his paper, you can know he doesn't have it if you know what it is. And that's what you get for copying off somebody else's paper. You get an incomplete work because you didn't do the work yourself. It's an absolute real field that goes on, and Sal Paez describes it, but I could tell you exactly how it works, man, but Jack doesn't have it. I wish he did. You know what I mean? But he doesn't have it. He's too involved in, you know what I mean, the big G and little g and all the math, that he has no engineering skill. It's just not there. And I don't think he claims that he does either. If it's not in a math format, he can't read it. Let's just put it that way. And if it's in geometry instead of algebra, he won't read it. So that's completely worthless. Yeah, not going to help anybody that wants to build something. That's for sure. He don't have it. I'll tell you why he doesn't have it. It's a very simple reason. He has no idea that you're pumping the ether. Because of that, he won't understand it. And you have to use geometry to spell it out exactly how it's done. And if you don't use geometry, the little points of on your little graph aren't going to cut it. You have to use geometry equations to do this, which isn't very hard. But yeah, if you don't pump that ether, man, you don't have it. And if you don't know why to pump the ether, then that's an even bigger problem. And the fact that it's even in there. And if you want to go and call it something else and some generic name they came up with, so they have to say ether, you still don't have it. Okay. Yeah, algebra killed the ether. Yeah. Or like trigonometry or something like that killed it. Hey. Wow. Yeah. Without the experiments, there's not a whole lot of real information there. There's just not. It's a bucket experiment. Dude, I'm sorry. I'm a little disillusioned with physics at this point. Some of their base knowledge is based on stuff that's laughable. Okay, it's just laughable. Okay, like what did they say? Conservation of energy is because some old lady dropped her balls. I mean, think about that. Conservation of energy is known because some old lady dropped her balls. They fell into the dirt and they made the same impression. So conservation of energy was born out of some old lady dropping her balls. I mean, come on, man. You gotta have more than that. Once you see that, you gotta change that. You can't leave that on there. It's just, man, it's wrong. Okay. It's like people go out and go, I'm going to debunk the electric universe theory. And then you ask them, how are they going to make their next invention? They go, well, I'm going to use lasers. I checked on how a laser was built. and it seems to use electricity. So, how did you debunk the electrical universe theory with electricity? I, did you have some other physics you were going to use? Did you maybe chemical, um, biological? Oh, you need electricity for all of your experiments. So, but when you look into electrical theory, you're saying that's not how it works. But when you go to recreate it in the lab, you're using the electricity to recreate the experiment. So who was wrong here again? I mean, it's somehow ignorant of them to even try to debunk it. It's like saying we're going to use regular physics, and then you look at it and they go, "We got this flat plane." Okay, well, hold on. What happened to the geometry and little points? Don't know. It's a flat plane. We put these little ghost objects up in a little bump. Okay. Oh, but we did it in like a Tron fashion where it has a grid, and we gave the little bump. That's how our physics works. You go, what? Did you not see these pictures from the space station pointing at the Earth and seeing it's a sphere? What happened to that? Oh no, we got a flat grid with a little ghost inside of it, and that's what it is. And that's how you base your math. Gotcha. I'm turning the channel about now because you don't know shit. Hmm. Yeah, sorry guys. AC and DC are man-made. The actual system we're in around the Earth is like DC, but it's not because it has to do with crystal oscillation. And much different thing in the end. And it takes more into account, you know, wavelength in your brain, stuff like that. It would have a better chance than you would in AC and DC. Energy is a bit different than that because you got to be able to convert everything as you go. You can convert it into AC DC. That's pretty easy. But think about it. When you want to run a generator, it automatically comes out as high voltage potential and not in AC or DC, and you got to convert. That's why you always have full bridge rectifier in every one of these. The supermassive black hole in front of the galaxy around it, which you're going to show us the black hole came first. It goes through it. Well, okay. Wow. You can make a node and it'll appear like a black hole. And let me explain this so we all understand this. If I create a node in the center of my Tesla coil, okay, and it's just a coil off by itself, nothing attached to it, it's going to create a vortex up and down. Okay, that's what nodes do. They're a spot in space where they picked up a frequency and that they can resonate with it and they can create energy from that. That's what it is. Now, if you're on a supermassive scale, that could be like a black hole. Does it mean we're living inside of a black hole? No. Does it mean at the center of the Earth there could be a miniature black hole that we call a node? Sure. Absolutely. We see it when we do our RAV experiments. I mean, just think about it. The center of that thing is basically a null zone. It's the node. It's right there in the center. And then we have consistent rings going around it. So what does that tell you about how energy builds out? It builds out in resonance. It builds out in rings. It builds out in plasma layers. Exactly how the sun's done. But it makes sense when you start looking at how things are done. You have a center power source in the cosmos, and then it builds out to every other one out from it, and then returns back to the source. It's just letting you borrow the energy when you go through it. That's it. This one controls all of it. You're all interconnected. There's no getting away from that. It builds out a node, and from that node, it builds out into centrifugal rings of plasma. It's proving out time and time again that that's what it's doing. And it pulls in the energy. Okay, that's why when you put two magnets together, it's not two toroidal fields fighting each other. It sucks into a node. In the center of that node, it's like a null. And it just creates the vortexes, and then the sides of just pull right in. The dielectric pulls right into it, just like that. It shows it. It's very simple. Okay, Ken shows it on his channel all the time, but that's how it works. But that's why everything else will work the same way. It all follows the same pattern. It just matters the environment and how you build out the environment around it. That's why I laugh. All these systems that I create, I can use the same ZVS for all of them. It's a running joke to me because you can do it with all of them. It's just based on the parameters you put in your system. Okay, that's it. Yeah, you can form galaxies from this stuff, man. You got to think about how everything's building out. If you know that it builds out in that way, and you know that energy builds out from the center point, okay, where you have the most energy, it builds out, and then it's taking the environment back into it. Why would you think the center of the cosmos is any different? They started to now, when you get into some of these shows, they start telling you, hey, not only do we have an asteroid belt, a Kuiper belt, but we have another belt beyond that. And we have a big old sphere that's running around the entire thing. And you go, oh, it'd be nice for you to tell us this before. Oh, and then by the way, we're not just sitting stationary inside of a galaxy, but the actual center is in rotation. So we're in a spiral around the galaxy that'll move like this around the center point. So what does that mean for us? We're not stationary in space. We're moving through space. That's not well known either. They don't seem to want to cover those topics and tell you the truth. So, yeah, there you go. Oort cloud. We've all seen the videos, man. I think a lot of us have seen just about everything out there. And once you put it together, you can start to see everything in the way it's going, man. We're absolutely running through the universe. That's why these ancient calendars predict things are coming through our solar systems. Why? Because they are. Because they come through every time we get around to this cycle. That's it. Yeah, defense, they're not missing it. It's in black projects, man. They call it a black hole, maybe. They got a lot of black projects out there, man. Which I don't have any problem with. As long as it's not out, regime changing. If they're putting it into research for UFOs or something, I'm all good with it, dude. No problem with that. I mean, they could just tell us on a flat line, hey, this is for our research we don't want to tell anybody about. Okay. That's all you had to say. You know what I mean? Not like you're going to get much of an argument out of the American people. We're like, well, that means we stay ahead of everybody else. Now you're talking. They're all good with that. So, let's see. Yeah, time zones. That's a whole different thing, man. Near Earth object removal system will work. Well, maybe. I mean, I don't know that they're going to work, but maybe. I mean, it's not like they showed us how the phaser works or anything. If they showed you that, then you'd be like, well, now we're talking. Shooting nukes up at something, man, ain't going to really got to get there, okay? Yeah. We have rockets that can't even make it out to space, and you want to send one up with a nuke and then try to hit something? Yeah, I don't exactly trust you on that point. If you're telling me you're going to send a missile halfway around the world, I tend to believe you. But when it comes to rocket technology that gets out of our atmosphere, sometimes yes, sometimes no. And and you had me going with the space race thing until we started to build other ones and they started to fail. Yeah. Toilet seats are $1,000. Wouldn't you like just to sit on one of those for a day? Yeah. They're nice gold toilet seats. Oh man. No, they used all that stuff for black budget projects. You know that. We don't just come out with systems that can destroy things and bunker busts like that out of nowhere. Oh man. Yeah, the Chicago thugs can do it. Huh, that's funny. I seen that video, man, when that guy was talking stuff on those agents. Man, is that a bad idea? Oh my god, dude. Yeah, no thank you. That's an automatic trip to jail to explain yourself. Yeah, good luck with that. Well, sounds a key, kind of. Kind of. More resonance than anything. I think you'll find that. More resonance than sound. Sound is an effect of all of it. But yes, it's definitely in there. Yeah. Jail for those, man. I don't know why they even think to say that kind of stuff, man. You gotta know better than that. You don't go out doing something stupid like that. That ain't gonna work for you. It's ridiculous. Yeah, I don't know, man. This world's starting to feel like it's upside down. Maybe it's just I'm paying attention more to. I mean, the stupid stuff people do out there than it is I used to. It's probably what it is. And then when you get older, you feel like the whole world's gone crazy. It really hasn't. It's been this way. You've just been doing other things. Huh. We've had 80s jams, man. UFO. Remember that when they came out with ET for Atari? What a disaster. Oh, wow. Yeah, no, they got some cool stuff in the military, man. I wouldn't be surprised if they actually had it. But going to Congress and asking for it, you're not going to get it. Okay. I think the government has a UFO? Yeah. Oh yeah. There's no question. Let me put it this way: if we can get close to it in the garage, or we can understandably come to a reasonable conclusion on it, it's only a matter of time. They take everybody's great stuff like Tesla, TT Brown, all of it, Odyssey car. They took all of it, man. They took every bit of it. And any patent that came through there, I mean, you see stuff on YouTube. I mean, YouTube is not even 1% of the patents they get to see. They get everything. How how do you not have it? I mean, it's really not that difficult once you know it. But they figure, the rest of us that won't ever understand it. And that's pretty much stupid to think that way. I mean, we're gonna run across it every once in a while once you see enough things on how it's done and the energy field. Once you understand how that works, and then you understand how to create vector directions and energy, yeah, then it's not that difficult. When you just look at the simple pattern on how they do the what was it, the bomber that they have, and you look at the fact that they're putting energy out there to reduce the compression going on the plane when you get to Mach. Well, it kind of tells you a story, doesn't it? I mean, unless we're out in left field, it seems pretty much reasonable to me that that's what they're doing. I mean, they're using different things on the outside. We're just learning about, certain things, you know what I mean? Uh, in order to get to nanotechnology on the outside of stuff, and they already have it. They already have had it. You think it's just radar, you know what I mean? Stuff that they're hiding? God, no. Way more advanced than that. Yeah, it's not radar shielding that they're trying to put on some of this stuff. They're running energy right through some of this stuff. I mean, come on now. We got to know better than that. Yeah, they don't open that stuff. That's why we do channels like this where we investigate everything that we build and then let it all hang out, man. That's why. So, yeah, once you figure out how to say this, Probably something I shouldn't say. I'll probably just leave that alone. But that, they created a couple different technologies added into one. And, they took crowd control devices, they took lasers, and they put them together to make one device. Okay. And I'll leave it at that, but it's very powerful and has a very much a disruption understanding to it. And it falls right in line with all the biblical stories, man, of how all this stuff works. I mean, if you look back at the Ark of the Covenant, it's based on resonance. Always has been, always will be. So same thing with the Egypt and the pyramids, and everybody puts it out as, oh, vibration or sound. They're not understanding that resonance works on the atomic level, and that is the key to all of it. There you go. It's the key to all of it. You want to create massive energy, separate some atoms without breaking them apart. There's a massive amount of energy there. You want to pull molecules apart? Okay. Massive amount of energy. Okay. You get right into the water car and all that with Stan Myers. That's all he was doing, pulling molecules apart, creating energy, putting them together, creating more energy. He knew how to separate them, put them back together. Yeah, it's like a tuning fork. Yeah. You should watch a tuning fork when it's on in slow motion. Kind of tells you a little bit of a different story of what's going on. Yeah, resonance is the most thing applied to energy. Why? Because you could take your voltage and amperage and turn it way down to almost nothing. And the resonance itself will produce enough energy because it messes with the radiation in the environment. So, yeah, it is more important because that's where the energy is. That's where it's created. That's where the energy is. That's where all of your over unity effects come from. That's where all your anti-gravity effects come from. Resonance holds a key to all of it. Yeah, people put it off as a different effect, sound or vibration. It's not vibration. If you're resonating something, you won't see it move one bit. They call it vibration. Well, it's a vibration on the atomic level, not on the physical level where mechanical stuff goes on. That's all just regular vibration. Resonance works on the atomic level. Oh. Hmm. Yeah, they have to tune it once it gets up there. Well, I'll be honest with you, man. If you're creating a field bubble, you're creating your own environment. You're creating a gravity well already. I mean, it's kind of hard to think of somebody not understanding gravity well and why you would need to pump the ether in order to have it. I mean, just think about it. Uh, Rotation's not going to get you there. You physically have to pump this thing. If you pump it, guess what happens? Get this energy compresses, builds out more, compresses, builds out more. This is why you pump it. It's very important. This is why string theory got it partially right. String series in 2D, it's wrong. Has to be in 3 dimensions, and resonance has to be the key part of it. That's your answer to string theory. Some of this stuff, they tried to bend it to become physics that we're normally used to. I can tell you right now, 50% of physics you can throw away. It's all the same effect. It just depends on the environment you put it in. It's really what it is. Which portion did you amplify out of the energy itself? And I'm not saying AC and DC. I'm saying energy. Which part did you amplify? They see it as different things, but it's not necessarily a different thing. It's just a different amount of energy. You can take half of the physics books and throw them away. You won't need them. Just won't. Let's see. You have a project to transfer power from one coil to another without losing much energy, but I need some time. I can transfer energy from a Tesla coil like the one behind me into, I don't know, about 20 coils and have more energy in those other coils than it's in that coil right there. Every time. So you have to entangle them, and you have to understand amplification of resonance versus just resonance. And I'll give you a trick to it. Resonance is what you see across your screen on your oscilloscope. Amplification is the distance it goes up and down like this. You can have the same amount of energy going into it, but if your oscilloscope has this much in there, it's going to run like crap. If your amplification's up here and going off the screen on your oscilloscope, then your power level has to come down because your resonance is way too high in comparison to it. So it'll build out energy in the extra coils higher than it does coming out of the primary unit. So that's how you do it. I've showed it on my channel several times. I can get this thing running on my primary system down to about 5 volts. And once I get it down to about 5 volts, everything else runs at about 12 to 15 volts on each one of them is the effect that you have out of it. So yeah, I've showed it several times on my channel, quite a bit. And yeah, you can entangle all of it. So once you create one works on the next one and the next one and the next one. And there's just number 2 coils all by themselves. There's no primary to them, nothing. It's because they're creating that vortex where it's pulling in the energy from the environment. That's where you're getting it. The resonance is seeking out everything in resonance with it and pulling it into your coil. That's why you have more energy into it. It'll do it every time. I just set it up, put it in every time. Yeah, you got to understand that amplification effect. Circuit's a little different. Well, yeah, that's cool. That is cool, man. Love to see it. Awesome. There's many circuits that'll do it. You do a burst at 60 hertz. Well, you can use low frequency. You can use high frequency. You just have to know how to tune the amplification of it. That's it. You can tune on 3 sides of this thing, by the way. You don't just have to tune where it is. Tune on the front side with trigger circuits and frequency generators connected to it. Tune in the middle with capacitor banks. Tune on the end by connecting 2 separate systems like a DC flyback or an AC flyback, either one, and put your Tesla coil to it and just set them on a bar. The AC or DC flyback on the outside, positive, negative, and the center being your Tesla coil, and use high voltage leaching in order to connect all 3 of them to make your Tesla coil run the entire thing. It'll take your Tesla coil from what looks like a DC spark gap into an AC high voltage spark, make more like lightning. So you can do it on all 3 sides there, beginning, middle, or end. You could transfer energy just like that if you know what you're doing. No problem. Yeah, gravity fire works like that. Don't ever put the motors on those, by the way. That's not going to work for you. That'll blow your motors, both of them, quick. Everything at like 1 megahertz. I made 1 megahertz frequencies. I have a coil that does it sitting right over there. Yeah, not a problem. I have Tesla coils. What is it? I have one that I last saw on my oscilloscope at 25 megahertz. Okay, a real small one. And I have one that I haven't been able to pick up on my oscilloscope yet. And what worries me is it's way over. My oscilloscope goes to 100 megahertz. I might be over that. So, yeah, it all depends on how you build it. I don't think that, I'll be honest with you, there's more power in low hertz than there is in high megahertz. You think it's the other way? Not necessarily. There's more amperage in low hertz. So if you're just looking for high frequency, sure. But if you're looking for high voltage, yeah, in the megahertz range. If you're looking for more amps, it's got to be down in the hertz range. So, and it's all because of how the systems work. Your your frequency controls your voltage and amperage in a DC system easy all day. AC systems violate that, and yeah, and they just work a little different. You'll see the effect. My gravity flyer runs at 25 megahertz through that piezo, and they're only rated for kilohertz, but it runs in the megahertz, and it shows up on the oscilloscope that way. Well, yeah, because you don't have any amps in there. You have milliamps at megahertz frequencies, but you can burst it. I'll tell you a story that happened to me. I have that Slayer exciter behind me. You put that circuit too close to that coil, and the power source, the same thing. What'll happen is the energy will build up in it and build up in it, and you'll be cranking that thing up to like 30 volts, man, and it still won't do anything. All of a sudden, it'll put out an EMP burst in the entire room, blow out all your electronics, just by that little coil right there. Because it's trying to resonate everything in the room with it. It's trying to take every capacitor and every circuit and everything and trying to resonate it with that. It's more powerful than you think it is. And then it'll just burst. It'll get to the point where there's too much energy in there and just burst. And then boom, right throughout the entire room. It shut off my computer system, my TV, everything, all of it. Not a problem. Shut everything down. So the one thing is different is it didn't fry all the circuits. It just shut them down, which, by the way, I have a different thing that I put into my gravity flyer device, and I can control that and just change everything on your computer and run all your passwords without even having to think about what they are. It'll hack your computer in seconds. It doesn't need it. It doesn't need your password. It takes your transistors and saturates them. And once it does, man, it clicks right past all your passwords. You don't even need them. You're modulating. Well, modulating works. If you're looking for bursts, yeah, there's other ways to do it. But yeah, if your technology is based on the burst, you can get a burst out of all of it. Hold on, Paul. Appreciate it, man. Yeah, it's all good, man. I've seen a lot of different systems work in a lot of different ways, man. It's all about how you can capture the energy if that's what you're looking to do. Sometimes you're not even looking to capture it. You just want it to run wild. I mean, I've created energy fields, man, where you start messing with all the speakers in the entire house. You start running your ground wire as your ground wire for your coils, right? Well, do I have to use the ground wire in my garage? No. I can go out back and turn on use ground wire from the house over there on that side. It's the same thing. It's going to go right through the whole thing, one coil to the next, and create a big distance between them. Nice. Well, what do you think that the two circuits must be synchronized to the same frequency, which is resonance. Okay, not just the frequency of the coils. Well, yeah, I know that. It has to be in resonance first, and any frequency that matches that turns into resonance with it. Okay, that is the frequency of the transmitter must match the frequency of the receiver as a whole. Well, that's exactly what I'm telling you. It does. That's exactly what I'm telling you. It does. You must first create a primary operating system that's in resonance. Then anything with that same frequency becomes in resonance with it. That's why it's entangled. So if I wanted to use the RAV that we created and I got a pickup coil that matches that frequency, guess what? That coil over here is getting the frequency. If I want to use a tuning fork to a transformer, and the transformer's winding has the same frequency as the tuning fork, that transformer will turn on and have energy in it. The geometry doesn't matter for that. It just matters the frequency. And once you start getting into transformers like that, you get into how much mass you created. That's why Tesla weighed all of his stuff instead of filling out with wire size. Yeah. Okay. Be cool, man. You got some kind of awesome system going on there, it sounds like, man. Love to see it. Lot of trouble with a lot of these things is the conversion. Not everybody understands how to convert things and why you convert them. I watched a video today. Somebody said the 4-bridge rectifier was giving him 300% more power. Well, yeah, maybe, but I doubt it. I've never seen one do it. I converted a lot of things, but not seen anything that does that yet. Yeah, love to see everybody's systems, man. See what you got. I got some pretty rocking systems, man. I haven't shown yet, but I'd love to see everybody else's. I bet you they're all based on the same exact thing. We just don't realize it. Let's see. The problem is that the transmitter frequency do not match the receiver exactly when the energy reaches the receiver. So you have an energy loss at a distance. See, I want to say this. You can't use the outside of the coil to get there. It has to match the resonance frequency. The frequency is not what you wind into it. It's the oscillation between the primary and secondary that's the resonance frequency. And the closer you have those two matched to perfect, the better off you are. Once you get that, then the other stuff starts to go away. Yeah, there's a little bit of loss of distance, sure. But grounding cures that. And because you're pulling a lot more energy at a lot further of a distance. But things are supposed to be that way. You got to understand you're in scalar, not conventional energy at that point. And you have to understand what scalar is. It's an energy and temperature differential. Once you understand that, you'd be okay to work with it. If you don't understand that, you're going to have a lot of trouble doing it. That's why a lot of people out there, they can't make two Tesla coils work together. They have no clue how it works. I've seen a lot of big channels have no clue how it works. Let's see. How do you make the Rodin coil to resonance 432 hertz, and how do you go about calculating that in the winding itself? One, you would have to have, how do I say this? A very large Rodin coil to get to 432 hertz. Let's just say that you don't have enough mass. You have an open core transformer, which means you don't have enough mass to get to 432. You could put a frequency generator to it and put 432 in, but it doesn't match the winding. Everything's based on the mass when it comes to the frequency itself. So if I run mine in 20 gauge and you run yours in 28 gauge, you're going to have a massively different frequency than mine. In 20 gauge, I'm getting closer to the hertz level, but I'm still in kilohertz. Okay, on the Rodin coil I have, the thing feels like it weighs a ton, and it's still in the kilohertz range. So the coil has to be quite large, or you have to put mass inside of it. You have to add metal to it somehow, just like a conventional transformer. That's how you get down to 432. There's it's not enough there. So, but how do you go about calculating it? It's basically how much frequency to weight you have. That's it. It's the ratio right there. Um, let's see. Tesla has a thing on how to build his coils, and he has some math in there in the Colorado experiments. I believe he has it in that lecture or that book he was writing down his notes in. Will tell you that answer. But I'm not going to go over the math here. I'd have to pull up a lot of stuff to get there. Let's just say you don't have a big enough rodent coil to get there. And I'm talking, I'll say it. I think probably weighs mine's about 6 pounds. Okay. And it's still out there. I probably have to get to over 20 pounds to get there. I'm going to need quite a bit. Yeah. There's different ways to do things, though, depending on which materials you use and stuff like that, I guess. But the open cores don't get there like that. Mm. Yeah, well, because you're adding a sine wave over your square wave, is what you're doing there by putting in the tone generator. Yeah, you could do it. If you want to set any coil you want to 432, just connect it to it, put a generator on it. That's it. Yeah. But to actually get there in frequency without touching it and just starting a tuning fork, turn it on, no. That has to be done by checking the frequency with the radio frequency method and finding out what's actually in there. Or you could sweep it with your oscope. You could do that too. Just got finished today. What'd you do? Just working? Oh man. Yeah, 432 is something good to have when you can't even say that on YouTube. It's a good frequency to have. Let's put it that way. Use a rod down the center to convert from cold to normal. You can if the rod's too big. Yeah. If you use the wrong size rod, then yeah, you're gonna just turn it into hot energy. And if you turn it up too high while you do it, you'll have problems there as well. Turn it into hot energy as well. Um, God, man, I had so many things where I put like a half-inch pipe in there, man, and it totally ruined the effect. Um, yeah. How would you know if the rodent coil is creating a coherent field? Energy doesn't stop flowing through how do I say this? Once you get this thing running in the frequency that coil is designated at, okay, then the field minimizes, okay, because your heat level minimizes. But as you put it in an off frequency, you're going to get more heat and you're going to get more magnetic value out of it, which is not what you want here. But that's how you get a bigger field out of it. If you want to mess with the environment, you have to get rid of that heat value and that magnetic value and start working on the ether value that you need to get to. How would you know it's working? Because the temperature would drop in the center of the coil. As soon as you take your little temperature laser and you put it to the center of the coil, you're going to notice a drop. It'll be colder on the inside than it is on the outside eventually. If you leave it on long enough and if you have a high enough differential, the room itself gets cold. Not a problem there at all. You can turn off the circuit; it'll run longer. Uh, Most circuits you turn off, they turn off right away because they're in hot energy. Cold energy circuit, man, you turn it off, it'll run for minutes afterwards. Yeah, that's how you know. Yeah, well, everybody wants to use 50 hertz and under because it's the way that they do everything out here. But I can tell you right now, that's not what their transformers run out there on the grid. Not at all. They have a different frequency. Right on, brother. Not a problem there. Yeah, I don't get involved in that kind of stuff, man. No, thank you. Yeah, some of these things, man, they're just putting frequencies in your coils because they're using a frequency generator to do it. That's why that whole stereo thing, your Rodin coil, they were doing that. That generator frequency with a signal generator, put it in your amplifier and throw it through there. And what is an amplifier? It's basically a transistor. I mean, it's amplifying like transistors do. That's what they're doing in there. So they amplify the energy coming out, and there you go, you get more energy. So it looks like an over unity effect. But how much energy does it take to run that amplifier? It takes a ton. So yeah, XY mode, by the way, that's awesome. If you've never played with an analog oscilloscope, XY mode is awesome. So yeah, you get a bunch of patterns in there, and then depending on ratio that you put them at and the amplitude you put them at, you get kind of a lot of cool patterns. Well, you're talking about like a burst is like I would say like a Tesla dynamo. Tesla dynamo to a coil. You come up with a big burst of energy, and you get a massive spike right away, and then the spike goes away and it goes back to normal energy. Pretty much the same thing. Hmm, nice. Yeah, you make oh man, Sheila, she was doing that with that oscilloscope, using the analog oscilloscope in order to make all that stuff. Yeah, that was pretty cool, man. So have it on my list, man, of stuff to buy right after a whole bunch of other wire. New tip work right in the secondary. Oh, did you guys see that, man? I, I'm trying to fool around with this thing, man, to put a tip on here. And it goes to the insert and how to put it in the plastic so it doesn't melt when you start railing on this thing. And you have to run it for quite a while to check it and make sure you're not melting the daylights out of your coil. Luckily, man, I don't have any problem with it. It seems to run pretty good on regular PLA. So I went ahead and added it, put that tip on there. I'll show you, man, the short video of it. Um, I hadn't put one on there before because of this reason. So yeah, see, man, it just comes out clean. And that right there is about 35 volts. So not super great or not super bad, but that's that NPN circuit when it runs out at 35 volts. And that's in DC, not AC. So not too bad at all, man. That tip right there cost me about $8 on Amazon. And then you had to put the insert in there, and then you had to solder the wire to the insert, which was the problem because it continuously tries to melt the plastic. So you got to be quick. So yeah, it's got a nice little halo around it. Yeah, pretty cool. Yeah, I like that one, man. That turned out fairly well. So just trying to do things. I run one wire energy, man. I don't usually use a tip on my coils because I run the wire down the center. But not everybody does that. So some people order them without the tip on the coil. Some people order them with it. I mean, whatever floats your boat, man. That right there, by the way, that coil, putting on that ZVS circuit and running AC through it with your Variac. Oh my God. 13-inch lightning bolts shoot out the top of that thing. That number 1 and number 2 coil are so in sync, man. It just rockets energy up into the air in AC. So, thing's a beast, man. Let's see if I have the video of that, man. I did it when the stuff wasn't even that great, man. Yeah, there's your configuration right there. You need that. That was something Sean came up with on how to use the AC on there with the 2 diodes like that. And everything looks wrong on it, but it works perfect. We're going to get this thing firing. We have about 8 inches. You can hook the 9. So you might even be hitting what? 10? Let's see. Yeah, that thing at points, man, gets way up there. There's a good one right there. So basically what I did is I checked up behind it and I wrote the numbers up all the way up there on the whiteboard behind it, man, so that you could see it. But this thing rocks, bro. Yeah, that Tesla coil, that sound of it just, oh man, it's awesome. So I don't generally run a lot of things in AC, but that one I had to. Yeah. AC is kind of wicked, man, once you start playing with it. Sean gets beautiful purple tendrils out of his, and I'm hoping that other coil that I got over there, that Utron shaped one, I'm hoping I get those out of both sides. Is the same tendril Sean gets? Yeah. So just haven't run it in AC yet, man. I haven't done all my DC experiments with it yet. So sometimes when you run things in AC, they like to melt down. So just want to make sure. I got that same coil. It actually died on me. Um, I I killed the inside of it, man. I put a wire down there, wasn't being careful, and scarred up the whole inside of that coil. Completely destroyed it. It sucked because it was my first coil of that kind of coil that I built. So it's kind of sucked, man. Nice. Yeah. There you go. Fireworks country. Put a couple of those in your front yard, freak the kids out to come by. Hopefully you don't hurt anybody. Yeah. Pretty cool, man. I'd love to have one of those giant ones in the front yard. Just turn it on, turns on everybody's car lights, pisses them all off. Nice. Thank you. Yeah, man, I'm excited. So yeah, go for that new channel, man. We'll set that up and we'll do all those coils on there, man. And I'll drop the links for everything. We'll do the 3D printing channel so we can learn how to build everything, and you guys will know how to do it even if you don't need somebody else to do it. But hopefully you get through it and be able to build whatever you want. It's kind of the goal of it. Not so much how to work a 3D printer, but how to do the file building behind it so you can build anything you want. Kind of more what it's aimed at, and how to build things for Rodin coils, Tesla coils, and I mean, just little circuitry devices where you can make little boxes and stuff to put them in. That's pretty cool, man. Some of the cool ideas, I mean, cat banks and stuff. I got to make a monster cat bank here soon, man. I've been dreading it. But I gotta pull that thing together, man, and build one bigger than the one you built me. And if I could do that, man, I'll be golden. I just need more of those 47 nanofarad capacitors in there. And then if I can get higher than that, if I can get like 100 nanofarad in there ones, and that'll switch it even faster, because we're working on that RAV. And so far I've started the RAV with the wrong power source. Okay. Then I started with an AC flyback. And then I went to my Tesla coil, that bipolar Tesla coil, and I built it with that. I mean, look, sky's the limits, man, on what we do with that whole experiment. So that's pretty rad, man. I'm pretty excited about that. So I did make the adjustable capacitor build. I did make that, and I put that on my channel. So if you're looking for a cat bank, it'll say cat bank, not adjustable. It'll just say cat bank on there. I put that on the channel already, I think. Let me see. I'll pull it up. Yep, here it is. Yeah, you can see it goes through, and we start out. I show you all the different things and where to put everything and where to cut the holes, where to measure out on your board, how to cut it. You mean everything, drill it. So I'm kind of going through it kind of fast, but you can see how it all connects in and soldered in. Yeah, let's go through everything, man. And then how the last connections are made. So those little tiny wires that drive you nuts. Nice. Well, right on, Darren. You already used it? Right on, brother. Yeah, those things, they work really, really well. Steam pick style metal. Usually, dude, I'll be honest with you, man. So I listen to all kinds of different music. So just a little personal, so you know. I was listening to Frank Sinatra, then Metallica, and then Offspring, and then came back with Righteous Brothers, and then and this is all when I walk around the track every morning. So I mean, it's just like whatever one song I liked, and I liked it because of the song. It doesn't have to be a certain genre. It just, you know what I mean? You got to listen to it. So I was also listening to a little bit of Elvis Presley in there. That one's cool, man. So I listen to all kinds of stuff, man. I used to listen to ska, a little bit of that. That was pretty cool. Got some cool songs in there, a little faster beat to everything. Let's see what else. Beastie Boys is one of my favorites, dude. Intergalactic, dude. I rock out to that thing all the time. So nice. Yeah. What else, man? If I'm building coils, man, everything's on the menu. Like the list that they put together, man, is so weird to everybody else who walks in my garage, but it just, dude, I love it. You get some Aerosmith in there, man. Uh, you know what I mean? You follow that up with oh man, who was that? Shakira. Listen to a couple Shakira songs in there, man. Then roll right back on that with some AC/DC, some Metallica. What else, man? Just all kinds of stuff, man. If it sounds good, I listen to it. What was I listening to? Kansas is what I was listening to the other day. Dust in the Wind. Yeah, Chicken Fry. That one's good, man. I love that one, and I like the one with the feet in the sand one. That one's pretty good, man. Just because you're kicking back and having a beer, that one's pretty cool. Ha! Little Right Said Fred in there. A little too sexy for my shirt. That's old school, man. That's like high school. Nice. Oh, sometimes 100 nanofast capacitors don't switch well. Gotcha. I will just maybe add a few more 47s in there. Yeah, Zap Brown Band. Yeah. That one he sings about feeling like a clown, man, where he's breaking up with his girl. Yeah. What's that one too? There was one. What was it? Oh man, they did it on when they used to do those MTV Unplugged, and I don't think it was Duran Duran. It was somebody else. They had a guy on there that was singing, and he was doing a really good job. And it was an '80s hit, and he sung it real slow. And it was much better, I think, in that version than it ever was as the '80s song. I can't remember, dude. Pink Floyd, The Wall, absolutely. Okay, yes. Sorrow as well. Oh, when Korn did the Pink Floyd song, um, that was rocking out too, man. I like that one. So both those versions were good. I think they did what another brick on the wall. So yeah, I like that one, man. Nice. Oh, a little Bob Marley in there, yeah. I can see that. There you go. I like some of that old school stuff, man. Listened to what Shaggy the other day. Um, Lean on Me. There you go. Oh man, I was listening to something else, man. Stuff I probably shouldn't even admit to, but I was listening to it. Yeah, I mean, you get into the Carpenters, a little bit of that, man. Yeah. Heck, man, I watch Soul Train if it comes up on there. I'm old and white, and I can't dance like that, man. So it's always cool to see. So yeah, I love that kind of stuff, man. Oh, what was it too? It was another dance one, and people danced all funky in that one too. Oh man, what was that guy? Uh, Skinny Bones or Bony something, Bony M, and they do all those cool dance moves, man. I watched that a couple times. That was pretty rocking. I don't know Elo. I know. Oh man, what's a band that came out of that side? ABBA. I watched ABBA quite a bit, man. ABBA was good. Oh, Bumping Down, that Bruce one. Nice. Hanson Brothers. Oh, I remember that, man. Long time ago. Long time ago. Oh man, it's like Milli Vanilli back in those days, man. Now nowadays they all lip sync because they're all dancing around. They don't sing their songs, man. Oh man, I actually listen to a lot of orchestra stuff too, man. So sometimes I didn't pick some of this stuff; it just randomly comes on, man, and kind of get into the groove of it. You know what I mean? Oh, it's like playing what is it? Green leaves on your organ, man. Kind of stuff like that. Pretty cool. Yeah, a lot of the stuff when you're in school, man. Yeah, yeah. Kind of miss that stuff, man. I was in band when I was a kid. Played the clarinet. Yeah, wasn't very good at it at all, man. I would have been better off with a guitar or something, but that's what they gave me. So yeah, music with the oldies. That's right. You gotta have a bunch of oldies, man. Gotta love a lot of those tunes. Yeah, I mean, just kind of rocking out when they come in the car. Yeah, I do that a lot. People look at me weird. Here's this old shaggy old guy listening to his oldies. Huh. Especially when I drive my 72 Nova, man. When I was driving that around, listening to the oldies, man. Or then walking on the sun. Well, to listen to that in there, man. That sounded really good in that car, man. That was a really cool song, man. Yeah, all those things, man. Even old school Michael Jackson songs are cool, man. Rocking to some of those. What was I listening to the other day? That jump song where the two kids crisscross were jumping up and down. I remember that too when I was a kid. Nice. Echoes in time. Very cool. Yeah, man, we're listening to a lot of old school. What's going on, brother? Yeah, Michael Jackson wouldn't beat it. That was nice. Yeah, Billie Jean, back when he played that. And then who covered that? Alien Ant Farm covered that one too. And then oh, what was it? Somebody's mom? Uh Stacy's mom or something like that. Oh yeah, that one always comes up on there. Nice. I still gotta put a music circuit on one of these testicles. I looked into several of them and I still haven't gotten it yet. Yeah, Smooth Criminal. There you go. There you go. That's the one that the Alien Ant Farm did. Tells you how old we were, what era we grew up in, huh? When you start listening to that stuff and you know probably all the words to it before they sing them. Yeah. Oh man, the good old days. Yeah, I thought some other stuff in there, man. I was listening to one guy play the guitar, and he was playing like dude, like beautiful Mexican music on the guitar, dude. He was rocking around like El Toro, I think is what it was called. And the dude was just rocking it, bro. He was like, nothing stopped him, man. I can't even use my fingers like that. And he was rocking that thing out. If you ever get a chance to put it up, man, um, I think the name of it was El Toro, and the guy just rocked it. So yeah, I love that Spanish guitar when they start doing that, man. That's really cool. What was that Cotton Eye Joe? Remember that one? That was an old school one, man. Oh man. Down memory lane. Gotta love those things, man. Yeah. Nowadays, man, they got some stuff that I don't even know about, man. What was it? Moonshine Bandits I was listening to the other day. Yeah, a bunch of girls in short shorts, man. That's what it was. That's what Moonshine Bandits was. Every song they did, that's all they had. I was laughing, man. Dude, Roy Clark is a monster, man. He can play a guitar. It sounds like a machine gun. That guy could do anything on the guitar. If you've never heard of Roy Clark, look him up, man. That guy is just amazing. Um, what was it? Riders on the Sun, I think he was playing, or Riders on the Storm, I don't think it was Riders on the Storm. That was somebody else. Um, something. It was a song that Johnny Cash would sing all the time, but Roy Clark played it. Man, it was just so much more cool. Right on, brother. Nylon strings, nice. Mark Knopfler. No, I haven't heard of that one, man. I don't know that one. Huh. Yeah, I listen to a lot of Johnny Cash, dude. Yeah, that one's cool, man. Gotcha. Dire Straits guitarist. Okay. I'm gonna have to look that one up then. Yeah, they got a lot of good guitarists, man. I I was listening to the Kiss songs and nothing bad about them, man. They're just so simple. Like the words are easy to remember because they didn't use many of them. They just repeated them a lot. So what was I listening to? Lick It Up. And this is why there's not much more words than that to that song. I was kind of laughing to myself, man. Don't get me wrong. Nothing bad to say about them, man. I love the song. I just didn't realize it was so simple. I guess going back and looking at it, it was funny. Hmm. Nice. Right on. Yeah, Friday, 0 point energy, Paul. Absolutely. Yeah. We'll have to get Joe's list back out that he did the first time he went through that because his list was good, man, on how it actually started. So I'll remind him of that as we go back through it, man. So, yeah, dude, what was I listening to? There was some stuff out there that I hadn't heard for a long time. Um, oh, it's Vanilla Ice. I haven't heard that in a long time, man. So that was on the other day. Listen to that. Oh, dude, right here, Country Sam's, dude, he's got a big Tesla coil, man. He come over and visited me, and he picked up a printer from me. Dude, he's got a big Tesla coil. He was showing me. So he says, let's see, finally got the DDSCTC rebuilt, which means he's got a monster coil. The best thing that you could do to the Rodin Coil, an aluminum spiral up, copper going around, nice, huge arcs, running to the wire in the middle. Okay, so just so you know, the thing's like what, 5 or 6 feet tall is what we're talking about. It's got big old wheels on it to roll it outside. He was showing me the picture. I believe it was sitting next to a pool or something, man, and he was disturbing the neighbors with it, which is right on, brother. So yeah, he's got a rocking Tesla coil, man. Totally awesome, man. So yeah, if you get pictures of him, man, send them to my email, bro. I'll put them up on the show. When it's firing off, I think everybody would love to see that, man. Right on, guys, man. Yeah, love talking Tesla coil. 8 feet. Oh, I'm sorry. I was insulting you at 6 feet. It's 8 feet tall. This I told you it's a monster coil, man. So, oh man, I'd love to see that thing spark off, bro. Oh, I'm sure, dude. That energy's got to be everywhere. I don't think you're getting out of it. You're in a zone when you're in that when you're around that thing. Nice. 8 feet tall. Wow. It's like that one that they did on the History Channel where they're trying to do that experiment by the water. Kind of reminds me of that, but I think yours is bigger than that one. What's going on, man? Nice to see you here. Yeah, 8 feet tall. Wow. Sets off every car alarm in the neighborhood. Turn it on. Boom, 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 boom. Lightning coming out of this thing. Awesome. Totally awesome. All right, guys. It's been about 2 hours, man. I'm gonna get out of here. Hey, um, you feel my teeth float? Yeah, I bet you do, man. That thing's awesome. Right on. Like I said, dude, shoot me my email, bro. Here, I'll put it on the chat for you in case you didn't have it. There you go, man. Yeah, just shoot me an email on that, man. I'd love to show everybody that thing. really impressive. So, hey, just real quick, guys, just another cheap plug before I take off. The Tesla coil that you see behind me that way is on sale right now. It's $260, man, with the NPN circuit, in case you guys wanted to pick that up. It's down at the bottom of the screen. You'll see all the stuff down there in the Shopify shop. So with that said, guys, I want to thank everybody for coming in and watching today and hanging out with me, man. I'm excited. We're going to be doing some Rodin Coil stuff, man. That'll be starting, by Monday, I'll be having some videos up on that channel for that Rodin Coil stuff. We'll start the geometry coil stuff. All of it's going to keep going, man. So it should be pretty cool to tune in, man. We'll do Wednesday shows on that kind of stuff. We'll stick with the Monday stuff for everything I do on this regular channel. So with that said, man, I want to thank everybody for watching and have yourself a great day. Don't forget 0 Point Energy is on Friday.